All right, folks, let's get started here. Good to see you all. Good morning to everybody. Could I ask if a few more people could turn on their webcams if your bandwidth supports it? I understand if your bandwidth doesn't, but I hope you will turn it on if you are in a place with enough internet connection to show your webcam. Okay. Um, all right, so let's get started here. Welcome back to Service Security. This is now week 15. And just to give you a sense of where we are, we have 2 more weeks of class. So we have a week 16, we have a week 17, and we have an exam week. But of course, we're not going to use exams. We're going to instead do a final presentation of everyone's projects. And I'll let you know in the coming weeks what we expect of the presentation and how to prepare for it. Okay. Of course, part of the presentation will be a live demo. So you have to give a live demo of your project working on Heroku, not just on your local computer. All right. So make sure that everything that you're doing so far is working on Heroku every single week, because it's very hard to go back and fix things if you are a couple of weeks out of date with Heroku. Every week brings its own challenge. All right. Okay, great. So welcome everybody. And this is week 15, and we are now, I would say, halfway through our module on authorization. Well, authentication and authorization with a little bit more emphasis on authorization. Okay. And we began last week, and we actually started talking about token-based authorization. So we did registration tokens, where we created tokens that we embedded into an email and sent it off to the user. And a nice thing about that feature was that we didn't have to create any database accounts anywhere, because that token kind of contained the preliminary information, just the username and email needed to create the account. And it was a token that cannot be tampered with, because remember, we're using NACL's authenticated encryption. So it's not only encrypted, it's also the same key is also used to produce the HMAC, or the hash block, so that it's both encrypted and authenticated, so it cannot really be tampered with. And then we used tokens also for authorization. And what we did there is we created a token that was stored with the session, but it was primarily used to let the API know that requests from the web application eventually came from a authorized user. All right, so it wasn't just to hide our session variables. It was something more than that. It was actually to make sure that our API can trust our application. So our application could hold on to a token from the API, and that would give the API confidence that the application that's making the request is making it on the request of an actual user, and it isn't just making a random request for user resources. Okay, so in a sense, we talked about that authorization token as something like a capability list, in that it allowed users to uh, give the app permission to make requests on its parts. All right, okay. So that was last week's topics today. All right, great. So let's see. So this week we'll talk about validation, and we'll spend quite a bit of time talking about policies and what those are and why those are important. Okay, all right. So one of the questions I asked, I think for the homework, was, well, I asked you to do a little bit of research into different types of HTTP codes. I'm going to look through your answers a little bit later, but this was kind of my take on things of when to use which, and it can be a little confusing. So one of the things about HTTP status codes is that they're a convention, they're an agreement between programmers about how to uh, inform others about the status of certain requests, okay? And it's best if we study them carefully and use them appropriately because others may use these status codes as a signal of what to do next. And a good example of that is with authentication and authorization. So we had a few codes that we could use, like 400, 401, 403, 404, when somebody makes a request to us and either they have not even authenticated themselves yet, or they're just making a request for something that they're not authorized to do. And one of the things that I've kind of found in my readings, and I'm going to look at your the things that you wrote as well to see your opinions, is that 401 is called unauthorized, but as I read more and more on Slashdot and other places as developers talk to each other, it becomes clearer and clearer that 401 is really not unauthorized. It usually indicates failed authentication. So somebody's trying to log in and they can't log in, and we say, sorry, you can't log in. All right. And so the question comes, should we be using 401 or 403 if somebody is trying to access a resource, or should we use 404 or 400? All right. 403 is called forbidden, which is a strange term because we don't really use that term in terms of security very often. But this appears to be the one that we should possibly use if people are not authorized. Okay, so if somebody's trying to access a resource, they are logged in, but they're trying to access a resource they don't have permission to access, then perhaps 403 from my readings is the one that we should be using. And one of the nuances between 401 and 403 is 403 invites people to try again. All right, so 403 tells people you're not authorized, try again when you have authorization. All right, whereas 401 to me says don't try to give me those credentials again. All right, so 403 is an invitation to try again, the way I read it. Okay. 403, however, does have the slight downside that we are informing uh, people trying to access resources that the resource is there, but you're not authorized. So it gives away a little bit of information. It gives away information that the resource exists. So if somebody's trying to access your API and just trying to find random resources and we tell them 403, then they'll know, oh, so this resource exists. Like they may be trying to guess ID numbers, primary keys, or things like that. So 403 gives away a little bit of information that the resource exists, and then they know, okay, so the URL is correct. I have to figure out the right authorization to get in. Okay, so for that reason, there's quite a few websites and resources that APIs that actually say 404 when you're unauthorized because they don't want to give you information about whether the resource exists or doesn't exist. And one example is GitHub. If you try to access a GitHub resource and you're not logged in, a GitHub repo that's private, let's say, and you're not logged in, it doesn't say 403 unauthorized, you can't access it. It says 404, I can't find this repo, because GitHub doesn't want you to be trying to guess correctly the URL of a repo. Okay. Any other thoughts about this or any other questions? Feel free to raise your hand, or if you have a question, you can raise your hand and then start typing it in the chat window, or else I can call on you to speak. Any opinions about any of these? You're okay with it? All right, well then I won't belabor the point, okay? Why do I put so much attention on this? Just because don't assume that it's always going to be your app that's going to be talking to your API. You could have other companies using your API as well. And if they misunderstand how you're using an HTTP status code, they may be messing up on how to follow up on certain things. So it's important to try to have to be as faithful as possible to the spirit of these HTTP status codes. Okay, great. All right, that's all I'll say about that. So the other question was about JWTs. So JSON Web Tokens is a technology, and I asked you if you could take a look at some of the research or some of the opinions, I'll say, online about using JWTs. So this is an interesting situation where we have this technology, if you will, that is developed in industry. It's not developed in a university, so we can't go to a peer-reviewed study or something to say, oh, this works, this doesn't work, these are the strengths and weaknesses. Unlike, for example, NaCl, which was developed in academia, it is developed by a professor, it has gone through, it has papers published on it, and we trust that it's been validated in powerful ways. But JWT is just something that was developed in industry, and uh, we have to wonder whether it's a suitable technology or not. Now, just to clarify, in the last week, we also created JSON tokens, like we would put like the user expiry date and things into a token, and then we would encrypt that using NaCl, authenticated encryption using NaCl. However, that's not JWT. JWT is a much larger protocol of how to do what we did more formally, and it allows a lot more things. It allows you to set the encryption standard you want to use, what kind of hashing algorithm you want to use, when it was created. Like there's a lot of other things going around with JWT and associated technologies around it. Um, so let me do a little polling. So just to kind of see um, what you all know about it and how you feel about it. So I've got one question for you. Before last week, how many of you, and please use the raise hand feature, how many of you have already heard of JWTs? Okay, got a few people, few more people. Anybody else? You've heard of JWTs before today's class, okay? So we've got about 5 people who have heard of JWTs. Okay, great. All right. Let me see if there's a 6th person. No, there's no 6th person yet. Okay, so about 5 of you have heard of it. Not bad. That's about that's less than a third of our class, but still a sizable portion. Okay, so let me ask you this: after you've done your readings, how many of you feel that JWTs are risky and we should avoid the formal JWT standard? Anybody? Welcome to raise your hand. Everyone feels confident about it? Okay. All right, let me ask the other question, just to make sure you're listening. How many of you feel that JWTs is safe to use and we should go ahead and use JWT libraries? All right. All right, good. So that's about half of you. Keep the hand raised, please. Keep your hand raised. Don't lower it yet. Just want to see how many come in. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so about half of you. What's going on with the other rest of you? So for the rest of you, do you have another opinion on it? You're not okay. So let me lower all the hands. Okay, I'll just lower them all. So how many of you are unsure, like you don't know whether you should or whether you shouldn't? Okay, so you're on the fence. You don't know. Could I ask one of you? People are like lowering their hands. No, not me, not me. Sorry, I'm going to just pick a person. How about Steven? Steven, could you just say a word or two about why you're sure or you're not sure, or why you are not sure? Yeah. Okay. But from your readings, do you get a sense that it's used or it's not used very heavily? I'm saying from just your readings online, do you get a sense that it is used heavily online or is not used? So then why are you unsure about it? Okay, okay, no problem. Anybody else? So anybody else who feels unsure um, about using it, want to have an opinion about why you are unsure? Anybody? You can raise your hand. Oh, Yen, you go ahead. Well, then it's pretty clear you should use it. Okay, I'm kidding. I'm kidding. Okay, all right. Okay, great. Thank you. Thank you. All right. Um, all right. So clearly it's clearly commonly used, and if you kind of search online, a lot of places are using it. Google allows you to send a JSON web token to authenticate yourself even. So it is actually pretty heavily used today, and it's heavily documented. There's actually a lot of places to go learn about it. There's like I'll put the links in the handout. They're very small, but if you download the handout, you can click on them. So there's places where you can go read about what it is, how it's used, and things like that. And there's also a lot of best practice articles that tell you how to use it, when to use it, and possibly when not to use it. So there's a lot of, I would say, positive discussion around JWTs, and you will see it commonly used in almost any company that's kind of doing distributed web applications or web applications today. Okay. However, if you do kind of search around and use the right keywords, you're also going to get a lot of people saying, stop using this. This is nonsense. All right. Um, and there's people who say, this is a bad standard. Just simply stop using it. It's extremely dangerous to do it. One article even goes to say, not even once. Don't even touch this stuff. Okay. Um, and there's also articles that are more specific about it. And again, this is another article that says, should you use JWTs? In many cases, the answer is no, and there are alternatives. And so don't use this. All right. Um, so a couple more things. Um, and so maybe a couple of things is, when should we use it? When should we not use this? All right. So a lot of the criticism comes around from two or three things that I've noticed. One is that the algorithms used in a lot of JWT libraries are not really necessarily state of the art. So there are some articles that simply say you don't have to use JWTs. You can just make your own JSON and just encrypt it with RBA with NaCl, which is actually what we're doing in this class. All right, and they say that that's as secure, if not more secure, than most JWT libraries out there. And I buy that. That's actually probably true. Um, but what's the other arguments against it? So after doing a lot of readings, this is my take on it, and you're welcome to have your opinion. So I put this little owl logo on the side. The owl means it's my opinion. Okay. So first of all, a lot of articles, in fact, even all the articles on best practices for JWTs, all of them say do not use JWTs just as a session variable. Do not use it as a way of kind of identifying who the user is and maintaining sessions. So there is a practice of many people using it in a web application and sending the JSON web token to the browser in a cookie, let's say, for example, and then they get it back and then they decrypt it, and every single time. So essentially, they're using it as a session variable rather than storing the session in the cookie. They are kind of using a JWT to encrypt the information in the cookie and store information in the cookie. And one of the reasons they're doing it is because they feel, well, then we don't have to write it to a database or to a session store. We can securely encrypt it and put it in a cookie. And I'll let you read the articles that are absolutely furious about doing it. And these two articles are actually cited by almost everyone, even the best practice articles always cite these articles. One saying, stop using JWT for sessions. The other saying more clearly, why JWTs suck as sessions tokens, okay? So essentially what they're saying is don't use JWTs for sessions. What should you use instead? And they say just use cookies, just use ordinary cookies. Why? A couple of reasons. JWTs can be hundreds of times bigger than just a session ID. So if you are kind of like making putting information into a cookie with a JWT, it's a very big, massive thing, and cookies have limits to the amount of space. All right. So one thing is the size, and of course then the performance, because every time it comes back, you have to unencrypt it and things like that. They say JWTs don't actually increase the performance of sessions because a lot of the time, even if you get information back from the JWT, like let's say somebody's has a shopping cart and they're putting stuff into a shopping cart on an e-commerce website. It's tempting to put it in a JWT and then put it in a cookie. But the argument is, well, that can be dangerous to do because maybe they have two browsers open. And they're shopping on both and they're adding on one. And if you're sending it back as a cookie from one browser, then you haven't recorded what's happening on the other browser necessarily. So they say that you typically need to end up reading the database anyway, or some central session store, maybe like you have a session store where you're keeping the shopping cart, you end up needing to read a centralized database of the session information anyway. So there's no performance benefit to using a JWT for sessions. The third thing is cookies are already signed. Remember, you have a session secret that's used to produce a hash of your cookie, which comes back with the cookie. So cookies are already signed. So by using JWTs, you're signing them twice, which adds no value whatsoever. The only potential value is that it's encrypted information. But then the question comes back, why don't you just store it in a session store or in a database where you can retrieve it appropriately? Because, and actually, if you read through the articles, they kind of make the point, you simply cannot put all the information into a cookie for the reasons that I mentioned. They may have multiple browsers open, multiple things could be going on. You end up needing to have a centralized place for session information anyway. So do read these articles, especially if you're working in a company that says, yeah, put all the session information into a cookie as a JWT and then get it back and decrypt it. So these articles are the ones that everyone is citing saying, stop doing that. You're adding no value. In fact, you're probably hurting your security in many ways, okay? So do take a look at those articles if you end up in a place where someone says you have to use JWTs. So where can JWTs be useful? They can be useful in the way that we're using them in this class between machines in a larger system. So between APIs, between an application and a web API and things like that, okay? So in our case, we're not using the JWT, we're not using a JSON web token to store what is the user doing. We're using it as a symbol of trust that the API can give to other machines. So we're using JWTs, I think the way they're supposed to be being used, that it's a token for machines to verify with other machines. It's not something you're supposed to be using with the user and putting in a cookie and things like that. All right. So do read those articles if you get a chance, especially if you're going to go and do web developments to kind of have a look at how you should and shouldn't be using them. So that's one thing. Don't use them to store session information in a cookie. It adds very little value. All right. Any questions about that point? Yeah, so Yenyu, your point that Yenyu says she's read an article that said due to the large application, some companies add session info into JWTs instead of a session store, and that's not a good practice. That's even if you read all the best practices articles that say you should use JWTs, at the end of it, they all say, but don't use it for session variables, all right? And in fact, let me kind of try to go and open up a couple of those best practice articles that I found. Excuse me. What's going on? Okay, my computer's really slow today with streaming and everything going on. So let me go back up one more. Let me open up this one. And let me open up this one. Okay. Okay. All right. So here's for example, is an article on JWT best practices, and they go on and on about what algorithms you should use and how to do it. Check this, check that. Point number 11, way at the bottom, right before the conclusion, they say, "Oh, by the way, don't use it for sessions," which is probably too late because by this time everyone has figured out, "Hey, I'm going to be using it for sessions." So they always kind of like cover their asses by saying, "Don't use it for sessions, please." Sorry. Let's see if I can open up this one. Um, Why is my computer so slow? Is it because I'm really trying to stream too much? Okay. So here's another article that says, use it, how not to use it, when not to use JWTs. Don't use it as a session token for regular web applications. So don't use them between your web application and the browser. There's no value in it. In fact, just use a session store like we're doing it and keep it secure like we are doing it. Okay. And they cite the exact same articles that I was mentioning about don't use it as session stores. Okay. All right. I will disagree with some of these articles on best practices in the following regard. Why are there so many articles saying don't use JWTs at all? So not just for session stores, but there's a whole bunch of articles saying don't even use them at all, not even once, never touch them. They're making a different argument apart from just session stores. All right. They're also making another argument. JWTs, unfortunately, was not created by security people. They were created by web developers who knew, I would say, less than adequate amounts about security. So it is an industry protocol, but it's an industry protocol made by people who were not very security savvy, unfortunately. And they introduced a lot of things into the protocol which are very questionable and very risky. One thing is, within a JWT, the formal JWT protocol, you are allowed to specify what kind of algorithm you want to use for encryption and for hashing. And if you remember from our discussion about NaCl, that's considered a really bad practice in security. Don't let people pick security algorithms because they pick really bad algorithms. And you don't know which situation, which algorithms you should use. That's something that cryptographers know much more than developers know about. So a problem with a lot of libraries is they allow you to pick and choose what encryption algorithm you're going to use. So a lot of the articles critical about JWT say stop doing that. Just make a JSON packet and encrypt it with NaCl. All right, and it'll be much better because you're not going to make a bad decision on what algorithm to use. So by and far, I would say if you're going to use a JWT library, my suggestion is don't use a library that allows people to pick what algorithms they're going to use. This is particularly dangerous because if you have an API, let's say, and it takes JWTs, and a JWT comes in and it specifies to use a weak algorithm, or by the way, a JWT can also specify to use no encryption algorithm. Your application will need to check what algorithms it's trying to use. And then it needs to make a decision, do I support this algorithm or not support this algorithm? This is exactly what I've been teaching this semester of trying to avoid. Avoid making decisions on what kind of cryptography to use. That's why we use the NaCl package, because a real cryptographer, not some like little web developer, really decided what to use and what not to use in terms of algorithms. And NaCl doesn't give you a choice. And that's one of the critical things about it is that don't give web developers choices on what crypto to use because we are frankly as web developers not equipped to make that kind of decision. So I would say avoid a JWT library that allows you to pick what kind of algorithm you're using. Make sure that the algorithms it does support, like make sure it supports NaCl, like a basic thing like that. I would also say if you're going to pick a JWT library, make sure it's made by a security organization, not just by some JavaScript hackers who decided to make a security library out of the blue. So by and large, these are my three things. If you're going to use JWTs, make sure it doesn't allow you to pick algorithms. Make sure that it uses only one set of algorithms and it's considered secure, like it uses NaCl or something like that. And make sure it's made by security people, not by web developers. All right. Unfortunately, in my experience, that eliminates almost all the JWT libraries out there, as far as I know. But maybe if you find some good ones for Ruby, for JavaScript, or for Python, or for other languages, do share them on our Slack, because I'd love to see some good examples. So if you find some JWT libraries that do not allow you to pick algorithms, that only use secure algorithms like NACL, secure protocols like NACL, and is made by security people, not by like web developers, do share them, because if I find a library like that, I would use it right away. I would much prefer to use that than make my own. Okay. But in this class, at least, I'm going to encourage you not to use a JWT library for the reasons I've mentioned. They're often not secure. They're not made by people who really understand security. And they allow outsiders to downgrade your security by choosing a weaker algorithm, potentially. All right. Okay. So that's my take on JWTs. Any questions about this, or anybody have another suggestion or any questions or concerns? So by and large, what we're creating, like what we created last week in terms of the auth token, it's like a JWT, but with no choices. And that's what I like about it. Like, don't give programmers choices about crypto, because we routinely make bad choices about crypto. Okay. All right, great. I'm just going to take a little break and see if anybody has any questions. All right, cool. So anyway, so that's my thing about JWTs. Now, why did I go through this exercise? I could have just told you last week, like, yeah, don't use JWTs, use this. I wanted to go through this exercise for a couple of reasons. First, um, me nor DJ Bernstein will be always behind your shoulder as you're going into industry and writing code, right? You will have other people telling you, you should use this, you should use that. I want you to get in the practice of, whenever you come across something security related, go research it and go find out what people are saying. Is it good? Is it bad? Learn to make your own choices and learn to push back against people who say, oh, let's just use it this way, let's use it that way. All right. So that's one of the things I want to kind of equip you with coming out of this class, is to be able to make decisions about security technologies, and to be able to kind of research it and say, okay, this is safe to use, or I think we should like hold off on using this, or here's some good reasons why we should be careful about this technology, so on and so forth. Okay. So kind of this kind of exercise of researching what it's all about is a big part of how you will have to operate when you're out in industry, because there's a lot of bad opinions out there. All right, cool. So that's JWTs. And we'll stick with the authorization tokens that we've been developing in this class for this semester, right? And once again, a reminder, we don't actually we don't actually put the authorization token into a cookie as the only way of storing information. We actually keep our information in the session store, and the authorization token stays alongside it, just so the web application can return it to the API to show the API that you gave this to me, so please trust me. It's just a token of trust between the application and the API, not between the browser and the API. All right. All right. All right, moving on. So today I want to talk about a couple of other topics. One is about validation. All right. So one of the things that I've been trying to stress this semester is that when we create these kind of distributed systems, or when we create any kind of like complex application or complex system, we always have this notion that hackers are gonna like break into our computers through like some weird protocol and like coming through some strange port, and they're gonna like do all this stuff. By and large, I would say the vast majority of hacks that kind of break into systems don't come through some unusual technique. Most of the time, the vast majority of attempts to break into systems come right through the front door. They come from people using your web application to send you some input through your forms. That's how they do it, okay? And the reason they do it is because your system is generally trusts whatever people tell it. And so we often allow people to type in whatever they want, and we trust what users have typed in. So because we have that door open, most hackers just come in through the front door. They just go open up your web application, they create an account, and then they type in some funny inputs to kind of break into your system. All right. So a lot of the most common types of attacks, SQL injection attacks, mass assignment attacks, just strange characters being typed in, and other things, these all come in through the browser. So your biggest security risk is usually the browser. It's the inputs that you give users. That's where attackers are going to come in, I would say 99% of the time. Very few attackers will be trying to find unopened, like insecure ports or doing something very sophisticated. It's a waste of time. Most applications can be broken into just through the web form itself. All right. So for this reason, we have to kind of talk about something that we briefly mentioned in a previous week. I think Tara was the one who asked us about validation, about validating whether what people are typing into the forms themselves. All right. So, um, and it's not just hackers. A lot of the things that will crash your system is just users typing in funny things into the system that your system is not expecting. All right. So this week, I'd like to talk a little bit about validation and to make sure that the input we're getting in from users is actually valid inputs. All right. And I'll talk about a couple of particular situations of input, and I'll talk about how we're going to do validation in a more formal way. All right. Okay. So let's talk about some interesting stories about validation. Let's start with usernames. All right. Generally speaking, when we make a system, we often accept, like so far, users can type in and make any username that they want, right? Like they can type in whatever name they want. We don't prevent them from making a particular type of username. And let me just try to like, and on the one hand, this seems like a good practice because, like, for example, somebody might want to use a username with Chinese characters. Somebody may want to use it with like English characters. By the way, I've got a question. On a system like Google, right? I can see, for example, looking at the Google Meet here, a lot of you have Chinese names in you've told Google your Chinese name, which is fine. But let me ask you a question. Does Google allow you to use Chinese characters for your username, not your full name, but for your username, like I'm Somia.Ray. Of course, my full name is Somia with a capital S, space Ray with a capital S. That's my full name. Or I could write Lei Songya, I could write my Chinese name in there as well. So, but does Google allow you to use any other characters than English characters in your actual username? Like my username is Somia.Ray. A little show of hands. How many of you think that Google allows you to use non-English characters to make an account? Anybody? Okay, let me ask. How many of you think Google only allows you to use English characters to make an account? All right. Okay, that's most of you. That's most of you. I assume the rest of you are not sure. Sure, I'm not sure either, actually. I haven't actually checked. All right. But let me tell you some of the issues around usernames. And I'm leaning towards the fact that we should only allow English usernames, even though I don't like the world to be all English. And let me tell you a couple of reasons potentially why. Um, there's a couple of issues with the characters that you allow in usernames, okay? And let me give you a demonstration. Um, here's one. Um, in Unicode, in UTF-8, for example, it's often possible for the same character to have multiple representations, the exact same character to have multiple representations. An example of that is maybe like some European characters like French or potentially Spanish characters, Italian, which have a little accent on them, all right? And the reason is, and well, so let's take a look at this. So let me try to do this. Where was I? In my application? Okay, so let me just, hold on. Let me just stop this. Um, Give me a second. Oh, my computer is so slow trying to multitask all these things. Give me a second. I just want to see why my computer is so slow. What's using this most crazily? Ah, it's the streaming. All right. Okay, so let's do a little demonstration here. All right. And let me go to encodings to kind of, oops, no, that was not it. So let me just try this one. So this is the, oh, rate console. I can just do pry. I don't have to do rate console. Wow, my computer is super slow trying to stream this in YouTube and Google Meet at the same time. It's usually not this slow, but this is kind of crazy. Wow. All right. So that's the, let's say the French letter for E with an accent. I can't remember if it's accent acute or accent grave. I can't remember. Um, and actually, there is another representation of this. It's the exact same character, but it's with a different representation. All right. And as you can see, these two are not the same code. It should be kind of obvious, but just to kind of make sure, these are not the same code, but they look absolutely identically alike. All right. And why is it that way? I'm not sure, but it's possible that, for example, it's possible that a lot of letters that are in the ASCII set, the original limited 120, the 7-bit ASCII, um, they involved European letters, but later when Unicode was kind of formalized, we created a new region of Unicode just for European characters. So some letters were duplicated over between ASCII and the formal set of European characters. Okay, so there is duplication within Unicode. So two people could have a username with this character, but they're actually using a different code. It's possible. All right. Similarly, there are characters which are not the same, but they look identical. They're actually not the same. They don't necessarily mean the same thing. So an example of that would be, let me see. This is the English letter A, or like the Latin, or like in the, let's just say for now, the English letter capital A. This looks exactly like the English letter capital A, but it's not English. This is Cyrillic. This is would be like a letter used in, let's say, Russian language or like Eastern European language. This is a Cyrillic letter, which looks identical to the English letter A. Okay, so it looks identical, but it actually is a completely different code, and it's not just a duplication of the letter A. It's actually technically a different letter because it comes from a different alphabet, different language altogether. All right. So we have the problem in that we can have two people. So let's say, for example, um, somebody comes in. All right. Oh, excuse me. So actually, I got that wrong. So let's say somebody comes in and uses the English letter A, and their username is Andy. All right. And we're okay with that. We say, sure, username Andy, that's fine. But then somebody else comes in and uses the Russian letter or the Cyrillic letter A, capital A, and they also look like Andy. Okay, our database would allow two people to have what looks like the same username, the same with the accent letter E. Okay, so one of the problems with accepting any kind of username is that you could have two people with what looks like the identical username, but they're actually different characters in Unicode. And this is risky because one of the ways that you trust other people on a system is by their username, right? Like if you get a request from somia.ray@iss.nthu, you say, oh, that can only be Somia. Nobody else could have that username. That's true, but if I've switched one of my letters with another Unicode letter that looks identical, then I could fool your human intuition of what is secure and what is not secure. All right. So it's really dangerous to kind of to allow people to type in whatever they want for a username. So one thing we can do to kind of limit this is one potential resolution is that we could do this trick, which is if there are letters which can be represented in two identical ways, it's the same letter, like it's the French letter E with an accent, then you can ask to get to normalize it to a single representation. All right. So this is actually let me see if I can CHR or no ORD. Oh, excuse me. This, I believe, let me see if this is also the same. Great. So what we can do is if there are duplicates, like actual duplicates of the same letter in Unicode, then you can do this thing called Unicode normalization, which tells your programming language, no, please resolve this to the simplest representation of this letter. Okay, so that's one possible resolution. So that if two people try to come in and use the same E accent, they end up using the same letter and there'll be a clash and we can tell people, no, sorry, this username is already taken. Okay, that's one resolution. However, it doesn't solve everything. In particular, as far as I know, it doesn't solve this problem. The Unicode normalize, oops, I'm not sure, let's try it. All right, so that's the English letter A. Oops, excuse me. And I'll say dot ORD, so I can, that's the number 65. And then let me take the Russian letter A, and normalizing it doesn't help. It actually, Unicode says, no, I cannot normalize these to the same letter because they're actually different letters that happen to look identical. All right. So normalization is one trick that you can use in some situations, but probably not suitable for many situations, particularly not suitable for usernames. This is one reason that you may find that a lot of websites limit you that your username has to be in English. It's not because we like English as a language, it's just to make sure it stays within the ASCII range so there's no funny tricks you can use to use multiple characters that look the same. Okay, so this is one kind of thing that we have to really take care of when we get usernames, that we don't allow people to type in whatever letters they want in the username. Keep it very simple. All right. So for example, here, this is a regular expression which says make sure that the username is only the lower letters A through Z in English, capital letters A through Z, numbers 0 through 9, or it's things like dots and underscores. All right. And actually, this full regular expression enforces that your username has to begin with a letter or number, and the dot or underscore can just come somewhere in the middle, right? Or even at the end. So that's one of the reasons why a lot of websites you'll see like Google limit you to English usernames. There's too many ways to play tricks with Unicode if you allow any kind of letters to come in. But then later, of course, it is a good practice to allow people to specify what they want their full name to be so that they're not stuck with just an English representation of their name. All right, cool. Any questions on that? Let me just take a second here to get some water, drink some water, and also see what questions there are. Accent aigu. Okay, great. Thank you, Billy. So Yenyu says the E seems to be different on your terminal. Yenyu, can you just take your mic off for a second and tell us how it's different? Okay, yeah, sure. Send it to Slack. Thank you. Thank you. So it's possible that, your system may not be set up for Unicode as well. So you may also want to check whether your system is is doing Unicode or not. So that could be a reason for a difference. I'm not sure. All right. Okay. All right, cool. So that's Unicode and usernames. Oops, excuse me. One more thing is passwords. So right now we have allowed people to type whatever password they want. We're not really checking what their password is. And we had a discussion earlier in the semester that limiting people to using passwords and or forcing people, like for example, do we allow passwords like this? Probably we shouldn't, because that can get, if somebody runs a hashing algorithm on us, even though we're using script, and remember the script algorithm or Argon 2 takes about 1 full second to hash a single password, so that's kind of prevents people from taking too many guesses. But if people have some really short passwords and we've allowed it, then it would only take some minutes or hours for somebody to be able to guess a password like ADF. So we probably don't want passwords that are too short, okay? How about lowercase passwords? Should we allow lowercase passwords? Should we allow people to have should we require people to have uppercase and lowercase? Um, should we require them to have special characters or numbers? Uh, what kind of password rules should we have? One of the things I discussed early this semester is it is important to ensure that people are using complex passwords if they're going to use passwords. However, what should our rule for complexity be? And one of the things we discussed, if you go back to our slides in the first few weeks of class, was requiring people to have like funny characters in it, numbers, uppercase, this, that. It makes it very hard for people to remember passwords. And that's when people end up reusing passwords, is when you make it really hard to remember. They'll make one fancy password and they'll use it on every single website, okay? And as we saw, actually, even complex passwords, especially if they're short, are not hard for computers to guess. They're just hard for us to remember, okay? So another approach that we discussed many like months ago actually was potentially, rather than looking at what type of characters people are using in their password, is to simply look at what is the entropy within the password and look at what is the kind of the space of the size of the password in terms of its complexity, in terms of entropy alone. And if you go back to that week, I think it was week like 3 or 4 or something like that. Um, One of the things we discussed was, instead of looking at what letters they're using, let's run an entropy calculator on it to see what kind of entropy the password has. So for example, here, the entropy calculator that we used would actually detect that a password with only lower characters, like this one, actually has a fairly low entropy. Why? Because they're actually repeating some letters, like the letter A is repeated, letter H is repeated. So this actually has a slightly lower entropy, all right? And more complex passwords, they don't necessarily have more entropy, but if they have more unique characters in a given space, then you do get higher entropy, all right? So my personal preference is not to look at what characters they're using, not to tell people, oh, you have to use uppercase, lowercase, numbers, funny characters, but rather just run it through an entropy calculator. It's totally fine for me if people use a lowercase character. So let me go see if I can find, let's see, secure, is it credence, secure, is it string security? I have a library this week called string security. Yes, string security dot, I can't remember what it looks like. Let me try to find it. String security. Wow, my computer is slow. Dot entropy. Okay. Dot entropy. And if I enter like just some letters like this, you find that this is the entropy value that it kind of gives, okay? And it's not that I need funny characters, it's more like I need to have a longer password with simple characters would actually have a slightly better entropy. All right. And it would be even better if those larger phrasers were not using the same letters repeatedly. So now I've got an even higher entropy. All right. So one of the things we discussed way early in the semester is it's often better just to count the entropy of a password rather than making people come up with complex rules and things like that, okay? So instead of telling them, oh, please make it 16 letters long and you must have a funny, you must have an exclamation mark in there, you must have a capital letter, you must have an underscore, just count the entropy and tell them, make your password bigger if you cannot, and use and use different characters than you're already using. All right. So this is potentially, so for example, if I was making a system, I would simply require people to have, let's say, an entropy at least higher than 3. And I found that in most cases, this is a pretty decent basic threshold to get more complex passwords. Okay. And you can even have a calculator that as they're typing that it's telling them, yes, it's complex enough or it's not complex enough. Okay. And it can tell people, try to make it longer, try to use different letters, than don't repeat letters, things like that, rather than giving them specific rules about special characters, numbers, and so on and so forth. Okay, so that was a discussion we had way back early in the semester, but I think it's time we enforce that in our system now and actually look at the entropy of passwords and ensure that they have high enough entropy. Okay, so these are some simple validations that we can do. And how are we going to do the validations? One way to do the validations is within our controllers, like when somebody submits a username and password to make an account, we can have a lot of if-then statements. Say, if the username is this, if the password has this, we can write a lot of conditional logic by ourselves. But there'll be so many places, so many forms where we have to add conditional logic, it can make our code really messy. I highly encourage people who want, and you should be doing validation of user input, to use a formal validation library. For those of you who took my class last semester, the validation library I suggest in Ruby is dry validation. It's a little bit hard to learn, but it's a very powerful library to do validation. Okay, so the way it works is this. You can create a class that does validation for each of the forms that you have. So for every single form in your system, like any kind of form where people will have to type in some input, for the entire form, you can create a validation class that validates all the inputs of that form. Okay. So for example, when people are logging in or they are creating credentials, let's say when they're logging in, for example, we can have a form just to validate like their login looks correct. All right. So I've got something called credence login. I hope I have something called login validation. No. Oh, sorry. This is on my application side. So let me go here. Oh, it's on the API side. Excuse me. Okay. All right. And yeah, all right. Don't know why my system is super slow today. It's not usually this bad, even with. All right. Okay. So I've got credence login. Where is it? Login validation, is that what it's called? Oh no, it's let me go have a look. It should be somewhere in my, oh no. You know what? I am in the wrong app. I'm just calling it the wrong thing. Sorry. Um, Let me just use the one that's here. I've got it as a different name in my application. form login credentials. That's what it's called. Okay, cool. So if I get parameters coming in from a system that looks like this, all right, so let's say that's my username and password, I can create a form validation. Let me move into my credence namespace. What's going on? Plans. Oh, yeah. Hold on. I've got to do this again. All right. So I can use a class called login credentials that I've made. And the login credentials look something like this. It's just a class that uses this dry validation library. It inherits from it. And I can simply specify the parameters like this. I can tell it, I've got a username that's required. I've got a password that's required. Make sure they're filled in. All right. And I'll show you more complex examples of validation, but this is a simple one that says when somebody's trying to log in, make sure they provide a username and password. Don't let them keep them blank. All right. And the way it works is this. Once you've got these parameters coming into your application, like through the web form, you can pass them directly, like routing.params, you can pass it directly to your validation class for that form. And then you can ask that object of that validation form, was validating it a success? And it'll say, yes, this username and this form had a username and password which were both filled in. Okay. Some other, not only that, you can also ask, well, what was the username? And what was the password? So this object credentials, which is now of type form login credentials, can both be queried to see, did it succeed? Like, was it correctly entered? We're not checking if it's the username and password is correct. We're not going to go into the database yet, but before we even go to the database, the web application itself, before it goes to the API and says, is this all correct? It can first just try to validate that a username was provided and that a password was provided. All right. Okay. And a sad case of that, let's say somebody just hit the login button but didn't actually type in the username and password. They just kept both blank or something like that. Then this credentials object, if you ask it, was it a success? It'll say false. So now you can check this credentials object to say, no, you did not enter things incorrectly. You can also ask it what went wrong. So you could say credentials.errors, and this will return an object which you can convert it into a hash. If you convert it into a hash, it'll tell you the username field had the following problem. The password field had the following problem. So it'll just tell you right away that these were missing, and it knows that these are missing because you told it they were required to be filled in. All right. So this is a library called Dry Validation that takes care of all these things, and it allows you to kind of do quick and easy validation and kind of specify it with a very high level language about what you're expecting people to type in into the forms. Okay. So this is a very simple example, but any questions on this validation library before I show you more complex examples? Any questions on that? All right. Let's move on to other examples. So login credentials was just one example. So this week in my web application, I have a module called form. And within that, all the forms, all the HTML forms have a corresponding validation, a form validation class. So this is for login. Similarly, when people are trying to register, I have an object to look at the registration. And what does this do? This makes sure that, remember when people register on my website, the first thing they have to do is enter a username and an email address. That's it. Then we send them a link with the verification and stuff. So on that registration form, I make sure that they're giving me a username, that the username is filled in, and that it matches a particular regular expression, which I have written somewhere else called username regex. Okay. And also I'm making sure that the size is at least 4 of the username. So I'm making sure that they're giving usernames that are small enough and that they match a certain regular expression. And the regular expression is in a different file, but I'll just show you briefly here. It's just making sure that it's an English username. Okay. Similarly, is making sure that the email is also filled in. All right. How about passwords? Here's my validation form for passwords. Like when users have clicked on the email verification link, they're brought back to my website and they're asked, please enter your password and enter a confirmation password. So basically enter the password 2 times, okay? So here's my validation form for that. This is kind of a little bit different because here I am asking, make sure that the password is filled in and make sure the password confirmation is filled in. But then on top of these simple validation rules, I've also declared my own custom rules, and they're called rules. And I have a custom rule for the password to make sure that the password, so I'm saying, please fail and say that the password must be more complex unless the password has enough entropy. And I've defined a function here called enough entropy. It basically uses my string security library to make sure that the entropy of the password is greater than 3. All right. So this is an example of it. You can write your own custom rules into this validation form. Okay. Here's another custom rule. This time I'm looking at the password and both the password and the password confirmation, and I'm simply making sure that the 2 are the same. So this is another validation rule for my form. Okay. And these are all happening on the web application. All right. Now, of course, you cannot do all the validation on the web application. Things like ensuring, like when people log in, making sure that the username and password exists in the database. This request still needs to go back to the web API like we did last week. Okay, but we can do some basic checks at the web application level as well. All right. Any questions on this? Anybody? So notice that I'm doing validation. Oh, excuse me. Where? I'm doing my validation, my form validation on the web application right here. All right. Of course, some of the requests, like for example, login, it requires a second level of validation, which is to go and talk to the database through the API. That we did last week, okay? But this week, I'm introducing some basic validation to make sure that what they're tapping into the web forms looks correct before I do more stuff with the API and things like that. There is one more option for validation. You could also do validation on the browser side, right? Like right in the browser, you could make sure that, hey, what they're tapping in looks correct. Any thoughts about this? How many of you feel it would be a better experience if we did the validation on the browser rather than the web application? Use the raise hand button. Yeah? Brandon, thank you for getting it started. Yeah? Any more people? Doing validation on the browser side? Only 3 of you think we should do validation on the browser side? All right, all right. Okay, we're getting a few more people. Great, excellent, excellent, good. Okay, at least several of you. How many of you feel? Okay, I'm going to just quickly lower your hands. Okay, how many of you feel it's a bad idea to do validation on the browser side? Feel free to raise your hand. Nobody? So let's talk about validation on the browser side for a moment. It is certainly a better experience for the user to do validation on the browser side because we don't even have to send a request back to the web application. We can right away, before they even hit enter, we could probably catch it and tell them, hey, something's wrong, right? So I am a big fan of doing validation on the browser side. However, it cannot be the only place you do validation. You need to repeat it on the web application side. Why? Anybody? Any thoughts? One of the risks of doing validation only on the browser side is that how are you going to do it? You're probably going to write some JavaScript on the browser side. But that's no problem. If I mean, the person on the browser side, they can change the JavaScript that you're providing them. So don't forget that on the browser side, like when you're on a browser, you can open up the page, you can see all the JavaScript. You could actually potentially change the JavaScript as well, or add your own JavaScripts. Okay. I have a funny story. I think I mentioned this before. I have a funny story of where I had to do that because I was like last year I was in the US and I was trying to file my taxes in Taiwan, and I logged into the Taiwan tax web system, and it wouldn't let me log in, and it said like your IP is like outside the range, and or something like this. Oh no, I know, I remember what it did. It basically did a check to see if the time zone on my browser was different from the time zone on the server. The time zone on the server is in Taiwan. I was in the US, and the time zones were different. So therefore, it detected that I was coming in from a different time zone, and it blocked me from logging in. And I was panicking because taxes was due like the next day. So I sent them an email. Nobody replied after a few hours. So then I realized, wait, they're just doing the validation on the browser side. So I just opened up my browser and I went in to check where they were doing the validation, and I just deleted that code. And ta-da, I was suddenly able to log in and do my taxes on time. All right. And I think I told you this story before because then I was scared. Oh my God, what if they catch me? And they catch later that, oh my God, I broke their validation. So I actually sent an email to the tax offices and saying, by the way, I broke your validation so I could log in from another country. Sorry. Okay. Just to make sure that, yes, I did something bad, but I'm being honest about it at least. Okay. And nobody replied to me. So I said, that's great. Um, but it's a good example of why you shouldn't do validation only on the browser side. Anyone can turn it off because the JavaScript is entirely for them to access. All right. And even if you have some safeguards that somehow make sure that they don't tamper with the JavaScript, they can add new JavaScript, no problem. All right. So validation on the browser side is certainly important, but it can't be the only place that you're doing validation. All right. So my recommendation is do validation on the browser side if you want, but you have to do it on the web application side. You simply cannot avoid it. You need to do validation on a computer that you trust. You cannot only do it on a computer that on the user's computer because that's entirely hackable by them, right? Okay. Any questions on that? I'm seeing some discussion on the chat board, so let me go take a look what's going on. Okay, Edgar you says same thing. Got denied with the time zone from news and government websites, right? So my suggestion is go open up your website, go look at the JavaScript. You can probably just turn it off and go access it anyway. All right, if they're doing it on the browser side, which I suspect they're doing. All right. Okay, cool. So validation is important, and but do it with a formal library rather than running a whole lot of if-then logic because it gets really messy and really complicated. Do it with a formal validation library. This is a place where I think it's better to use a library rather than writing your own. Okay. And I gave you some examples here, but you can go have a look at my other validation libraries. So I think you can you'll see that this week I've got 5 different validation libraries. Some of them, like auth, actually has several validation classes within it for login, for registration, for passwords, and so on and so forth, okay? You will also note that you can actually define your own custom error messages, and I'll let you look at the documentation. So if you look at the dry validation library, you can go read the documentation for dry validation. It's right there. And you can look at my examples. You can actually create your own YAML files. Like for example, within my forms directory, I've got a directory called errors, and I've got a whole bunch of YAML files which write out more specific um, uh, error messages for particular fields and situations. Okay. A nice thing about this validation library is it allows you to specify multiple different languages as well, so you can have validations in multiple languages. Okay. So I do encourage you to play with a very powerful validation library in whichever language you're using, but in this class in Ruby, I suggest you use dry validation. Okay. Okay, great. Any last things? Okay, a couple of things. So this week in my web application controllers, you'll notice that I don't just use the routing.params and send it straight to my service object. That's what I was doing last week. Last week, I was sending the routing params straight to my service object. This week, I'm doing something a little bit different. The routing params first goes to my form object. So these validation classes that I'm making, they're technically called form objects, okay? A form object is an object that captures and validates a collection of inputs coming from a web form. So I first send my routing params to a form object, and then I check if it was a success or a failure. If it's a failure, then I show an error message and I redirect them to a different website, to a different site, to a different page, okay? And only if it's not a failure, then I call my service object and I pass along my registration object, all right? By the way, my code may have changed a little bit from what you're seeing here, so do look at my code on GitHub rather than copying it from here, because the form validation library I'm using is changed a little bit in the past year or two. So my code on GitHub is going to be more accurate than this, but this is the general idea. Okay. One more thing, in that module form that I created, I have a file called form base where I'm also creating a couple of helper methods called validation errors and message values. And what this does is these are two methods that take my errors coming out of the form validation, and like, for example, if I have credentials with errors in them, I'm going to I have to make a hash out of it. But then I've got a method called validation errors that takes that hash and makes it into a nice helpful string. So for example, validation errors takes the keys and attaches it to the values of that hash and puts them together with all the other keys and values. So you get a nice message like username is missing and password is missing. All right, so I've got a couple of methods that just create some helpful error messages that I can send along to users. All right, so you can take a look at those as well. Okay, let me see if there's another question here or comment. All right. Okay, so that's the validation library. Email validation is a really tricky one. It's very tempting to say, listen, when I ask users for a username and email, I should make sure before I send them an email, I should make sure their email address looks correct. And it's very tempting for programmers to think, I know what I should do. I should use regular expressions. There's a joke in software development that if you have a problem and you feel that the solution is to use regular expressions, now you've got two problems, okay? Because regular expressions are complicated. And actually, emails are very complicated, and you shouldn't assume that you know what the structure of an email looks like, all right? You may not realize it, but if you go to, I think, where is this? This is on Wikipedia. If you go to Wikipedia and you go to their Wikipedia's article about email addresses, you may think email addresses look like this, pretty and simple at example.com. But of course, most of you are smart. You know, well, they can also have periods in it, okay? If you have something like Gmail, you can also have a plus symbol in it, okay? So validating emails gets hard. Now you may say, okay, that's fine. I will allow people to do whatever they want, and but they just have to have multiple letters, then an @ symbol. But it gets more complicated than that because you're allowed to have email addresses with just one letter, like x@example.com. So if you're going to write regular expressions, you should also handle that, okay? What else? You're also allowed to do things like you can have a period at the end of your username on a lot of email accounts. So if you're going to write a regular expression, you've got to handle that as well. You're actually allowed to use really funky characters. A lot of email domains allow you to have funny characters, allow you to have quotation marks, allow you to have very crazy things in them. It's all part of the email protocol, so that's also allowed. So if you're blocking people with emails like that, you're technically disobeying the protocols of what email usernames can be. All right. In fact, you can have crazy emails like this. That's totally allowed by certain domains. Maybe Gmail doesn't allow you to have it, but other domains might allow you. You could even have an email address like this, just a blank space with quotation marks at example.org. Okay. So it really does get complicated. And of course, now with IPv6, this is actually a legitimate email address. You can just provide the IP address in an IPv6 format. So my suggestion to you is don't try to get smart and create a regular expression for email. There's a website called Email Regex that provides you fairly comprehensive, but not 100% proof, but fairly comprehensive regular expressions for email. This is the example for Ruby. This is a regular expression to handle most, not all, most of the use cases of what an email address can look like. My suggestion to you, don't even go there. It's too complicated, okay? What email is allowed to look like is way too complicated. My simple thing is just check that there's at least one ampersand in there. That's all you've got to check. If they've got one ampersand, at least they haven't entered a username by accident instead of an email address, okay? And then the second thing is send them a verification email. That's all you got to do, okay? So in my system, at least, all I do is make sure the email regular expression I use is just to make sure that they have an ampersand, and then I send them an actual email. That's all I do for email verification, okay? I would not suggest you to go too much more crazy than that, because the world of email is incredibly complicated. And yes, you can even, there's some questions. Let's see, Tara says, my email has a dot in it, and a lot of websites say it's not valid. Yeah, Tara, that drives me crazy because they should know. And actually, Gmail has this really nice feature that I think most of you are aware of it. On a Gmail address, you can use, like, for example, my Gmail is somia.ray@gmail. The dot is optional on Gmail, by the way. In Gmail, Somia Ray and Somia.Ray is exactly the same thing to Gmail. So you can add as many dots as you want to Gmail. Actually removes the dots internally. All right. So dots are optional in Gmail. First, second of all, Gmail allows you to put a little plus symbol and have a keyword after your email, and you can change that keyword to be anything you want anytime you want. And I use that, for example, if I'm going to a shopping website, I may use somia.ray plus shopping. And that's allowed. It's the same as somia.ray@gmail. And I use that so for different types of activities, I use different emails. So if someone's spamming me, I can catch it quickly. All right. So, but a lot of websites tell me, oh, the plus is not allowed in your email. I say, what are you talking about? Gmail allows me to have a plus symbol. So why don't you allow me to have it? So it really infuriates me. Okay. So yeah, Tara, I get really pissed off with that as well when people tell me your email is not valid. No, email me. Trust me, it's valid. Okay. Um, uh, I have the same problem with websites like that say, hey, enter your mobile number so we can send you an SMS. And I give them my Taiwanese mobile number, and they say, this is not a valid mobile number. I'm saying, what are you talking about? Just send me an SMS. You'll find out if it's valid or not. Don't ask me if it's valid or not. You know, um, I have a website just yesterday that I had that problem with. I think it's PayPal. They ask you like, hey, if you have a Taiwanese phone number, enter the number, and enter my mobile number. They said this is not a valid mobile number. I'm like, trust me, it is. Don't use validation. Just send me a message. Okay. Yes, Billy, you can have a dot at the end in some email hosts. I don't know if Gmail allows you to do it or not, but a lot of email hosts allow you to do it. All right. So anyway, so my point is, don't get crazy with it. Just check an ampersand and then send them an actual email. That's it. All right. Cool. All right. Any other comments about email? But email is complicated. All right, cool. All right, let's take a little break. So this is validation. It's going to be a little complicated, so please try out these validation forms. Once you get the hang of it, it's a really powerful tool, and it'll save you a lot of ad hoc if then else crap coding, okay? A lot of conditional coding. So try to use this validation library this week, okay? All right. Feel free to tap any questions, but let's take a little 10-minute break, and we'll come back and we'll talk about security policies in a moment, okay? I do request that while you're taking the break, do turn your webcam off. I will ask you to turn it back on after the break. So let's take a little 10 minutes, and I'll be back at little before 10:40. So between 10:35 and 10:40, please come back online, okay? Thank you.